Valence bond theory, learning the super easy concept of VBT through various examples. Firstly, let me teach you that what are orbitals. Well, consider hydrogen atom. We know that hydrogen atom has only one electron and it is constantly revolving around the nucleus. If I ask you where it is revolving, I hope you know the answer. The electron is either revolving in x direction or in y direction or in z direction. Thus one can say that the electron of the hydrogen is present in this three-dimensional region or spherical region around the nucleus. Now listen carefully. This three-dimensional space around the nucleus of hydrogen atom where we can spot electron is called orbital. Therefore, we define orbital as the three-dimensional region around the nucleus where probability of finding an electron is maximum is called orbital. For example, the shape of s orbital is spherical, the shape of p orbital is dumbbell, and the shape of d orbital is double dumbbell. Thus note it down that atomic orbitals are the three-dimensional region where we can look at electrons of any atom. Now let's consider this hydrogen atom and this hydrogen atom. We know that each hydrogen atom has one electron. Now these two hydrogen atoms will react with each other to form a hydrogen molecule H2. Now here is the interesting part of the lecture. Have you ever wondered or you ever asked your teacher how the orbitals of hydrogen atoms combine together to form a hydrogen molecule? What about the shape of hydrogen molecule? What about the bond energy and bond length of a hydrogen molecule? Can you answer all these questions? Well, to learn about big boss, I mean bond energy, bond length, orbitals overlapping and shape of a molecule, we look at the valence bond theory or VBT. Remember that this is my personal mnemonic big boss about VBT which you will never find anywhere. So if I ask you what is valence bond theory or VBT, your answer is simple. Valence bond theory teaches us big boss. I mean bond energy, bond length, orbitals overlapping and shape of a molecule. Also remember that VBT only explains the formation of a covalent bond. It does not explain ionic bond and metallic bond. Thus note down all these important points. Now what are the postulates or key concepts of valence bond theory? Well, the first point of VBT is the formation of covalent bond. It states that covalent bond is formed by overlapping of atomic orbitals of two atoms. For example, consider hydrogen atom and chlorine atom. The last or valence orbital of hydrogen atom is s orbital and the last or valence orbital of chlorine atom is p orbital. The valence orbitals of these both atoms will overlap together to share electrons and form HCl molecule. This region is called overlapping region, which has maximum density of electrons. Hence VBT teaches us that covalent bond is formed by overlapping of atomic orbitals. The second point of VBT is the type of orbitals. It teaches that only half-filled orbitals overlap to form a covalent bond. For example, in the case of HCl molecule, the s orbital of the hydrogen atom has one electron and the p orbital of chlorine has one electron. So they both are half-filled. As a result of this, they overlap together to form a covalent bond in HCl molecule. Also, let's consider this case. Here, there are two electrons present in s orbital, while one electron is present in p orbital. The covalent bond does not form between them because s orbital is complete, having two electrons. Hence, VBT teaches us covalent bond is only formed if both the orbitals are half-filled or having one electron each. The third point of VBT is the spin of electron. It teaches that the spin of electrons must be opposite in overlapping orbitals to form a covalent bond. For example, consider this case. Here, the spin of electron in 2p is upward, while that in 1s is downward. Hence, these both orbitals will overlap together because they have opposite spin. Secondly, consider this case. In this case, the spin of electrons in either orbital is upward. They will not overlap together because they have the same spin. Thirdly, consider this case. In this case, one orbital is completely filled. We need both orbitals to be half filled, so they will not overlap together to form a covalent bond. Thus, VBT teaches us the spin of electron must be opposite in orbitals to overlap and form a covalent bond. The fourth point of VBT is the identity of orbitals. It teaches that orbitals retain their original identity after overlapping. For example, consider the s orbital of hydrogen and p orbital of chlorine. The shape of s orbital is spherical and that of p orbital is dumbbell. When hydrogen atom and chlorine atom react to form HCl, still the atomic orbital of hydrogen is spherical and that of p orbital is dumbbell. It means that they both have retained their original shape or original identity. But remember that the energy of atomic orbitals is high before overlapping. Once they overlap, then they have lower energy in a molecule. Thus, VBT teaches us orbitals retain their identity after overlapping. The fifth point of VBT is number of bonds. It teaches us if there is one unpaired electron, it will form one covalent bond. If there are two unpaired electrons, it will form two covalent bonds. If there are three unpaired bonds, it will form three covalent bonds. And if there are four unpaired electrons, it will form four covalent bonds. For example, in case of nitrogen, there are three unpaired electrons present in each orbital. Hence, nitrogen atom share its three unpaired electrons with one electron each of three hydrogen atoms to form NH3 or ammonia. So, due to three unpaired electrons, nitrogen atom forms three covalent bonds. Thus, VBT teaches us the number of bonds. The sixth point of VBT is the intensity of overlapping. It teaches that overlapping between orbitals should take place at optimum or suitable position. For example, consider overlapping of two atomic orbitals of A and B atoms. In this case, the atomic orbitals overlap at such a position that the repulsion between the two nuclei is minimum. So we say that overlapping between orbitals take place at optimum or suitable position. While in this case, the two atomic orbitals overlap so close that the two nuclei can almost touch each other. So this is the wrong case of overlapping and it will not happen, while this is the right case. Thus, VBT teaches us the intensity of overlapping. The seventh point of VBT is bond energy and bond length. It teaches that the extent of overlapping decides the bond energy, the bond strength or bond length. We can say that the extent of overlapping is directly proportional to the bond energy or bond strength. If overlapping is greater, bond strength or bond energy would be high. For example, consider overlapping between these two p orbitals. Let there is minimum overlapping between the two orbitals, so the bond energy will be smaller. Secondly, minimum overlapping means that the two orbitals will be away from each other, so the bond length will be high. Now consider overlapping between these two orbitals. Let there is maximum overlapping between them, so the bond energy or bond strength will be high. Secondly, maximum overlapping means that the two orbitals will be close to each other, so the bond length will be smaller. Hence, note it down that if the overlapping is minimum, bond strength or bond energy will be smaller and bond length will be high. If the overlapping is maximum, bond strength or bond energy will be high and bond length will be smaller. The last and eighth point of VBT is the sigma and pi bonds. It teaches that there are two types of overlapping occur between atomic orbitals. Axial overlapping, which is also known as head-to-head overlapping, and parallel overlapping, which is also known as side-to-side overlapping. For example, when two p orbitals overlap like this, It is called axial overlapping or head-to-head overlapping. Remember that this type of overlapping will always form sigma bond, while when two p orbitals overlap like this, it is called parallel overlapping or side-to-side overlapping. Remember that this type of overlapping will always form pi bond. Thus, VBT introduces the concept of sigma and pi bonds. In the next lecture, we will learn more about sigma and pi bonds.